My name is Michelle Baker. I'm the Dean of the College of Science, and I want to welcome you all to tonight's opening presentation of Science Unwrapped's Celebrate Undergrad Research series. Utah State University boasts the nation's second oldest undergraduate research program, second only to MIT. And so this entire year, we're celebrating 50 years of undergraduate research. We're excited and honored to welcome Utah State University President Elizabeth Cantwell this evening, the first USU president to ever open a Science Unwrapped event. Like many of you, President Cantwell is a STEM enthusiast interested in all kinds of learning, including science and engineering. President Cantwell graduated with a bachelor's degree in human behavior from the University of Chicago and went on to earn a doctoral degree in mechanical engineering from the University of California, Berkeley. She also completed an MBA degree in finance and entrepreneurship at the Wharton School of the University of Pennsylvania. President Cantwell served the U.S. National Security Mission as the Lawrence Livermore National Laboratories Director for Economic Development and Director for the Engineering Mission Strategy, and earlier as a Deputy Associate Director for Global Security at Oak Ridge National Laboratory, where she worked with the U.S. Departments of Energy and Defense, the National Nuclear Security Administration, the Defense Threat Reduction Agency, and NASA. President Cantwell accepted the helm of Utah State University in 2023 after having served university research leadership at the University of Arizona and Arizona State University. She's a fellow of the American Association for the Advancement of Science. President Cantwell is a stalwart champion for research, curiosity, imagination, and learning. Please join me in welcoming President Elizabeth Cantwell.
There's way too much information, so what I think you should remember from that little discussion is, remember, I started by majoring in psychology, and I ended by being an engineering researcher and building things that physicists, where's my physics students? Yep, that physicists think are gonna work, but they don't always work until the engineers build them. So my job, and I can't believe I'm the first president to introduce, I just can't, it's stunning to me. Every president should be here every time. We'll just see what we can do about that. But we've been doing this for 16 years. So this is one of those classic things that are called public service, where we tell you about science, and this time you actually get to meet some of our science undergraduates, but the fact is that it's a service to us to have the public come in and allow us to just talk to you about what we do and why it's important. And this year in particular, it's really important because this is the year of undergraduate research. And that is a designation we have created for ourselves, but we've been in the undergraduate research business for 50 years, which is only bested by MIT. And it's not really fair because they started as an institution before us. But what that means is we've been bringing our students, our undergraduate students, into the research world that we occupy for 50 years. So we say here at this event, we bring the scientists, you bring the questions, which means every one of you should be prepared, figure it out, find a question about something that you get to see after all these people talk at you. Find a question. You've heard, I know you've heard this, there's no bad questions, there's no wrong questions. I am here to tell you that I am the queen of dreaming up the weirdest question I can think of, because even if it comes from a place of not knowing what I'm talking about, it engenders a conversation in which I learn more about whatever it is that's going on, and that is our hope here, that you will be able to see what it's like to be immersed in a field of science, learn how to ask dumb questions, because that's really how the world works, seriously. Figure out the dumbest question you can ask, and you will engage in an enormously interesting conversation. And then really show you and your families what the thinking process is like in the variety of fields of science that we train people in here. We are blessed tonight to have a whole bunch of our undergraduate researchers telling you about what they do. So this is also a service to them. They need to know that if you know the secret core of good science is being able to explain it and tell other people what it is that you are doing. Our faculty are pretty good at that. Our undergraduate researchers are getting better and better and better. So I think I will just end by saying that undergraduate research celebration for this whole year, you'll have more opportunities to engage with our publicly, as the public, with our undergraduate researchers. I invite you to think about questions, make them as dumb as you think they can possibly be, and I guarantee you they will be some of the most interesting. And no matter how big you are, figure out a question, bring it to the world outside of these doors that's going to show you a lot about what we do. And if you think that you're interested in science, this is the place to be. So I welcome all of you. I'm really glad you're here. I'm really glad I'm here because I still can't believe that no other president in the history of the 16 years that we've been doing Science Unwrapped has come to the table. And I will demonstrate the art of asking dumb questions out there in the world. So thanks, everyone. Are you introducing?
Thanks, President. I remember a big classroom like this at Stanford University where I did my PhD. Right on the front, it said, keep asking questions. So keep asking questions. It's great advice. Welcome to Science Unwrapped. I'm Boyd Edwards. I'm a member of the Science Unwrapped committee and happy to have you here today. Just a few items of business. At the end, there will be questions and answers. And if you'd hold your questions until that time, that would be great. So during that question and answer period, you may remain here in the room to do the questions and answers, or you can go look at the undergraduate posters, or you can go out and look at the activity booths. We have 26 volunteers that are manning these activity booths, and we have 8 undergraduate research poster presentations. 3 of the volunteers manning activity booths are new. Capime lab, right? Is that right? Yeah, sorry. So the Capime lab is new. The Bridgeland Amateur Radio Club, if you're interested in that. Spanish Health Care Club. Also, we got the Cache Valley Astronomical Society, near and dear to my heart. So all of those things are available to you. It is a pleasure to welcome our featured speaker, Dr. Jessica Habashi, to kick off this Science Unwrapped new series of Celebrate Undergraduate Research. Dr. Habashi completed her undergraduate degree in biology at the University of Utah and earned a doctoral degree in cell biology from Yale University. A principal lecturer at USU's Brigham City campus, she is a champion of undergraduate research. As a faculty member in the USU Department of Biology, Dr. Habashi teaches a range of courses and maintains a robust research program in education and conservation ecology. She creates opportunities to involve students in research from the moment they begin their studies at Utah State. That's big. That's what we do here. Dr. Habashi is often a student's first mentor in research, and she gets them started right. In recognition of her efforts, she was named the College of Sciences Undergraduate Faculty Mentor of the Year in 2022. Dr. Habashi is active in the Biology Undergraduate Student Association's statewide campus committee and the statewide honors program, along with the Affordable Learning Resources Committee, which are aimed at creating inclusive opportunities for scholars throughout Utah. Dr. Habashi holds certification in Boston University's online inclusive STEM teaching program, along with certification from the American Council on Education and the Association of College and University Educators. Please join me in welcoming Dr. Habashi.
Thank you. Okay, hi everybody. So my first name is Jessica. My last name is Habashi, and I am here to tell you that I have one of the best jobs in the world. So I teach biology at Utah State University, not here in Logan, but I'm teaching in Brigham City. And one of the reasons I love my job so much is I get to do a lot of fun things. Now, teaching in the classroom, working with students who want to be nurses or PhDs or dentists, physicians, I mean, that's great. I love being able to work with them while they're still on their way towards their goals. But one of the funnest things that I get to do beyond my classes is I get to work with students who want to do science. Now, doing science, right, we can say, oh, they're doing some research. What does that really mean? Well, if you imagine you're asking questions, you're kind of curious about something, you make some observations, try to figure out what other people know about it, maybe you design some experiments, you have to analyze some data that you collect, you make conclusions, you share your findings. I think you've got the idea, but I want to ask you from your perspective, who does science? Is it just students in universities? Help me out with this one. Yeah.
Everyone can do science, really, because people at science fairs, participants in like studies and papers, anyone can do science. All you have to do is study graphs, make findings, and make sure everything is up to quota.
Okay, I love that. Now, I love the very first thing you said, which was anyone can do science. Really? That really, I would emphasize that. We're not kidding. There's no age requirement, right? Nobody's going to say, you have to be the top of your class and to be able to do some science. No, not at all. What we want from people who do science at the university is people who are just curious about the world, people who like to ask questions, and people who like to work together to try to find answers, because we work as a community. Now, I have another question for you, which is, where did the ideas come from when you say, I'm going to study a topic? Yeah.
Their mind.
Their mind? Okay.
Or they get curious about something.
Okay. Curious about something they've seen or read?
And also, sometimes they just get bored.
Okay. How do you think that's going to lead to some questions? Just start thinking, and who knows where your thoughts are going to go. Absolutely, yeah.
So I could think sometimes scientists could get their ideas by stupid questions like someone was talking about.
Oh, exactly. Exactly. You just ask a question and say, you know what, I'm just going to see. What do we know about this? Yeah.
I also thought that when there's like a problem, some people, like scientists, like try to find get an idea to fix that problem.
Yeah, sometimes you can identify a real need and you say, what's going on here? Can we understand the scope of the problem and what do we do about it? Okay, absolutely. Well, I'm going to tell you a story about some research that we've done in Brigham City. And our idea came from a problem. And I was approached by one of my colleagues in Brigham City. Her name is Cindy Peterson Lanham. Now, she takes care of the grounds at our campus. What that means is she's in charge of making sure that the walkways are clear. She makes sure that the vegetation is healthy. So she's doing a lot of maintenance and walking around our building regularly. Now, she noticed over time that there were a few dead birds here and there, not every day, not even every week, but she was concerned about that. And she contacted me and she said, well, this is what I've seen. I'm wondering if we've got a problem. And I said, I don't know. Let's look a little deeper. Let's see what we can find out. Now, I was very lucky in that I had a colleague here in Logan, Dr. Kim Sullivan, who was already studying a similar issue. She was looking at 9 different buildings on the Logan campus, and she had students who'd been working for a few years, and what they would do is literally walk around some buildings every day, and they'd be looking for evidence that birds had struck the windows. And what they would be looking for would be the carcasses. Now, that's the dead birds. And they would have to keep careful records on their findings. And they had been able to find over time that there were some really problem areas. And what they did about that was they started to make changes to the windows. So they were way ahead of us, in other words. But Dr. Sullivan helped us find some articles and websites that we could read to see what was already known about the problem. Now, one of the first things that we learned is birds, they don't see transparent glass. So we've got lovely modern windows, which, if they're clean, right, they're so easy to see through. Well, birds don't see that. They don't know what that is. They think it's an open space. Not only that, have you ever seen those buildings that have super reflective glass? Imagine, a bird doesn't know that's a window. They're saying, oh, wow, beautiful blue sky, clouds. I'm going to fly right through there. Okay, you can get an idea of where the problem might begin. Now, another issue for birds that's been recognized is when we have plants inside of buildings, and I mean a lot of plants. They'll make beautiful vegetation displays that might include entire trees. Now that can be visible from the outside. So first off, bird doesn't know there's a window separating them from that tree. And so they try to fly right in. They hit that window, and the problem is especially big at night. There's a lot of big buildings, they leave the lights on at night. And so even if the glass might be reflective during the day, you might be able to see those plants at night from the outside. And indeed, there's a lot of documentation about increases in bird window collisions at night. Now, you might say, well, when people create buildings, maybe they could, put up some kind of barriers or something that the birds will kind of say, no, I don't want to go through there. And yet, birds, many fly through 4-inch wide openings, and vertically, a lot of species might only need a couple of inches of space. Now, the more we learned, the more we saw there were a lot of factors that could influence the likelihood of birds hitting a building. Food sources, that was another big one. Now, what you've got here is this was from a study looking specifically at bird feeders. And they were looking at fatal window strikes and looking at the distance of the feeders from a window in meters. Now what this shows is if you put your feeder really close to the window, like within a meter, that's not much of a problem, but it starts to go up as you start coming away from the window, and 10 meters, you're about 32 feet there. So when you think about buildings that may have trees that produce berries that birds might want to feed on, well, it's kind of the same issue as the bird feeders. You got a food source that might be at a problem distance from the windows. Now, it may not sound like much, 10 meters, but let's put this into perspective. Now, I want you to think about how fast can you run over a distance of 10 feet. Now, some of you might go on treadmills, and you might know like what your put your settings at in miles per hour, but how fast do you think we might go? Now, I never go above maybe 3.5 miles per hour. You think you could go faster than me? Yeah, I bet you could. Well, if we think about the fastest humans, like Olympic runner Usain Bolt. Now, the fastest he was ever clocked as part of a race was between, I think, meters 60 and 70. He was going about 27 miles per hour. And his average speed is about 23. Pretty fast, right? Do you think that's faster or slower than a bird? What do you think? Slower? Think the birds are even faster? You would be right. Okay. Birds reaching up to 30 miles per hour just within that distance of 10 feet. Now, 10 feet would be the distance from the ground to the rim of a regulation basketball hoop. So that gives you an idea of how amazing that really is. So if you come back and you think about how fast they may be moving when they are fairly close to a window, it's not surprising that when they hit, maybe about half the time it kills them instantly. Maybe if they're lucky, the other half the time they get stunned, but they recover. Of course, during that time period, if there's a cat nearby, they might be preyed on. All right, now we had all of this knowledge, and we wanted to figure out if we really had a problem. Now, we expected that we would, simply because nearly 1 billion bird deaths per year in the US are due to window collisions. And if you check out what we have here, this is sources of bird mortality, that means deaths, in the United States annually. All right, now there's the window collisions. Now this is not necessarily really high-rise buildings. It's a lot of low-rise buildings, including homes. And the number of deaths per year from cats, whether it's house cats or just wild cats that might be living in a field, is less than half. And if you come down here, we see, compared to the cats, power lines cause less than half the number of deaths per year. And it goes down from there, pesticides, hunting, vehicle collisions, communication towers, and wind turbines actually cause the fewest. So we expected that windows at our building might be a problem. Now here's another picture of where I teach in Brigham City. Look at this design. Based on the background that you have, you see anything wrong with this? Yeah, please.
The glass is way too reflective, and it looks like there's an opening between the two mountains to go through.
Okay. And you can actually see some of the mountains through those upper windows too, if you look really closely. Absolutely, so a lot of reflective glass. You can see right through the mountains. Yeah.
The building kind of blends in with like the rustic reds and the tans of the valley. So the birds aren't that smart. They would think, oh, this is just a shortcut through to get to the mountain.
Now, speaking of kind of looking like the surrounding area, you notice this? Now, this picture was taken fairly early after the building was completed. We also got the vegetation. So, yeah, we've got some issues with, a lot of fields around within about that 32 feet from those windows. We've got the reflective glass. And what else do you see here? Yikes! What do we got? Yeah, we got the tree. Okay, now this tree, people were excited about this tree when it came. It's a species, it doesn't grow here, it came from back east, it was really expensive, and they had to get it all set up. And I mean, it's beautiful. It's got a really interesting root system. But there's all the windows around it. And at night, yeah, you can see that tree really clearly from the outside of the building. So we knew we had some obvious flaws which could contribute to window collisions, so we spent some time, 2017 to 2024, doing a census. Now again, that means walking around the building. It took us about 15 minutes every time we did it. And we'd start from the side of the building and come out about 6 feet. And we had to look under the bushes and around the garbage cans and the benches and so on, looking for bird carcasses. Now, that wasn't the only thing we'd had to do. We also needed to look at the windows themselves, because sometimes what you see is a bird-shaped smudge. And on occasion, these smudges will have attached feathers. And we would count those as well. We'd document it. We'd always record the date, the time, where we were around the building. And we did keep the specimens. They were frozen for further analysis. Now, as this project really got going, I needed some help. Now, a lot of students stepped up and said, this sounds really interesting, especially students who lived in Brigham City. Like, well, we've got the bird refuge really close by. This is an interesting question. Now, Taylor Kenyon was a student who came into my biology class her first semester at Utah State. Now, she didn't have a lot of confidence in herself. She hadn't been a particularly good student, didn't have really high grades in high school. She really wasn't even sure that she belonged at a university. But from my perspective, she was friendly. She asked good questions during class. She had an obvious interest in science. And I said, do you want to come and help us? Now, she almost turned me down, I could tell. She said, well, I don't know. I might ruin everything. I don't know if I can do this. But she tried it out, and she really liked it. She became the coordinator for our study from 2020 to 2024. So that is all through her schooling at Utah State. Now, during that time, Taylor and her other student researchers, they did more than just study this problem. They became educators themselves, right? They would teach about it at the summer science camp in Brigham City during the summer. Now, they would give interviews. This actually is a picture from an article in Utah State Magazine where they interviewed Taylor to ask her about the study and the scope of the problem. Well, last year was a busy year for us because we'd gotten quite a bit of data from our census. We'd been counting these birds, and we were ready to analyze. One of the findings that came out of this, significantly more collisions happened in the fall. Now that word significantly, let's talk about that for just a second. If you do a study and you're comparing different things and you say, wow, looks like a bunch more hit the windows in fall than any other time of the year. Is that random? Or is that a meaningful difference? Now, the way we can figure that out is we do some little mathematical tests. You might have heard that word statistics. And indeed, this was a meaningful difference. The statistics said that significantly more collisions happened in the fall. Now, we also found that more birds were hitting the east side of the building. Now, the east side is right here. So this is not facing the street, not facing any parking lots. This is facing a lot of trees, vegetation, and further out, it's an open field. And there are food sources there for birds. Now, this remains kind of an unanswered issue for us, though, because notice, it doesn't say significantly more birds were hitting the east side of the building. The problem was that when we started the census, not everybody was writing down where they were when they found the carcass. So we didn't have quite enough information to analyze. Now, Taylor, as she grew in confidence during the project, she said, I'm kind of interested in what effect, if any, age is going to have. So she looked into how to age birds. And she found she could use the heads. Now, you kind of move the feathers out of the way and you're looking at the skulls. Or you do what she did and you're analyzing the feathers for patterns to show you if they're in their hatching year, if they're in their second year, or if they're after their second year. So she chose this, and she analyzed all of our specimens. She found that adult birds had significantly more collisions. Now, this is something we'd like to know more about because there are some other studies out there, including one from the University of Utah, where they had actually the opposite. They had juvenile birds that were more likely to hit. Now, at this point, we've kind of gone through phase 1 of this project. And now we got to do something else that every scientist has to do. We got to figure out what to do next. So what do you think we could do? Any ideas? Yeah.
Maybe you could test like if certain types of glass. Maybe you like change up the results. Like if certain types of glass affect the bird's collision rates, you can see if
Okay, and there are studies out there where they've tried that. That's a great next step for us. There are different things we could do to the glass, decals, UV tape. There are things we could do to make the windows more visible, and then we would repeat our census and see if we do see a decrease in collisions. Other ideas, I think, did you have one?
Use one-way glass, and other than using one-way glass, one side is visible, one side is a mirror, the other side you can see through, but you can make it more tinted, but make it so you can see from the inside, but you can't see from the outside.
Okay. And yeah, we certainly could look into what can we do directly with the glass. Could we change the glass? That's where we might need to have some conversations, right, with the administration about costs and what might be feasible to try. There are, the kind of wrappings like you see on buses and the little dots you can get on glass actually etched into the glass. Yeah, Matt.
was there a certain
That would be another thing we would love to address. Is there a certain species that was hitting more often than the others? Our problem, again, is numbers. We need to keep going. So right now, we have just anecdotal information. You know, we had more juncos that struck the building, but we didn't really get a lot of numbers when it comes down to the total number of specimens that we had. But that could be something we do. Just keep going and see what other questions we can ask about that data. Well, as far as this first phase of the project, this is just a tiny representation of all of the people who work together to make this happen. Now, up here, these are all students, and there are at least 24 who gave short-term help to the project that aren't listed here. We've got in the middle some Utah State University faculty members who gave their time. And at the bottom here, these are my amazing coworkers from Brigham City, some of whom would actually fill in to do the census when we didn't have a student available. They'd go on their lunch break and just walk around the building. They didn't always want to collect the birds, but they would let us know if they found them. And I think that is the great Aggie spirit, and I love my job in so many ways, but this is one of the funnest things I get to do. Now, what's up next for Taylor? Like I said, she didn't have any confidence coming into the university. She wasn't sure she belonged. Thought she might mess up the research project. Well, she graduated last year, and she was the biology department undergraduate researcher of the year. She was our speaker at graduation. Right now, she is finishing up a manuscript. She's written up the results for this, and she's going to try to get that published. She's also currently in Washington. She's finishing an internship in marine ecology at the University of Washington. She's getting ready to apply to graduate school. She wants to be a PhD. I said, what after that? She said, I want to be a university professor. And I want to help students do research. That is fantastic. Now, in closing, I just want to give each of you a moment to pause and think again about who does science. Could you do science? I'm hoping that the answer is yes from everybody. And I'm really hoping that at some point, you all are going to get that opportunity. So thanks again. Thank you for listening to me talk about this wonderful job I have. Okay, did we have any questions? Now, as you're kind of deciding whether to stay or go, let me just say that we do have some window decals on one of the tables outside. They are helpers, basically, like you said, attach something to the glass or put something on the glass that would make it more visible for the birds, something you can take home. And there should be enough for everybody, so I hope you'll grab some on the way out. Yeah?
What is your lab working on right now?
So right now I'm in the position where I've got some educational research going, where we're implementing some curriculum changes and studying the effects of that. The census is on hold because I need to get a new cohort of students. So that's the only thing that's really holding us back right now. One of the neat things, though, Matt, is Spencer Smith, who was one of the students who worked on the project, is now working in Brigham City as a lab instructor. So it's wonderful to have him as a new colleague. Anything else? Okay, I guess not. Thanks again.